students. Today we are going to discuss about collision resolving methods. So last class we discussed what is the collision, by which reason the collision is arise. So once again recollect the definition of the collision. If the same index place, if one more element is going to place, in that situation is called a collision. That means if the same index already one element is stored, if you want to store another element on the same place on the same index, that situation is collision. So there is a problem in modified hash function. So let us move on some other suitable solutions to resolve the collision problems. Generally, the solutions are classified into two categories. One is open hashing, another is closed hashing. Open hashing is also called as closed addressing, and this is also called as open addressing. So under open hashing or closed addressing, we are using the method to avoid the collision is called as chaining method. Under the closed hash and open addressing, using the methods are linear probing, probing, and quadratic probing, and last one double hashing. Last one is double hashing. So chaining is some other way to ask the question, is linked representation or linked list. Okay, so these are the general possible solutions having in the hashing methods. Okay, so these are the open hashing and closed hashing methods to resolve the collision. So where it is, by which reason the collision is arise. So let us it is overcome with the suitable solutions. Okay, let's look at one after another how the collision is resolved. Okay, so let us look at on open hashing, how it is resolve the collision problem. Okay. Take some list of elements at the key space. Okay, this is a key space, and these are the elements. Take any elements in either it is order or any random order. You can take the elements. Okay. So these are the elements. One more element I need to take 30. So as usual, hash function is modified hash function is h of x equal to x mod division of 10. So there is no modification in the mathematical modified function. Okay, and as usual take the memory location. As you know that how many parts the memory will be partitioned, so 10 parts. Okay, 0 1 2 3 4 5 6 7 8 and 9. Okay, it is classified into 5 parts, sorry 10, partitioned to 10 parts. So now as well apply the mathematical function on these inputs. Okay, so let us take h of x5 is 5 mod 10. So if it is mod 5 10, the remainder is, if the value is less than 10, so the remainder is still 5. It can store the fifth index position. Next 7, take input 7 mod 10, the remainder is 7 only. Okay, it can store 7th position in the memory. Next 15 mod 10, this procedure already I discussed in the last class in the modified function. So once again, remainder is 5, the remainder is 5 already in the same index, already element 5 is stored. Then we want to, there is no replacement, so then, so that is the situation is called. So then how to overcome means you can add a list of which element, 15. Okay, which element is 15, that will be stored in the linked list form. Okay, next element is 13 mod 10, then remainder is 3, so 13 is stored in the place of index 3. Next similarly h 25 modulo division 10, remainder is again 5. So then it is further extend, it can extend the node like linked list form, it can connect it to another new node. Next h 33 mod 10, remainder is 3. So already third index having 13 element, so then extend the connection, here stored 33. So no other elements are having in the key space, so that which is having the list form, if there is no element then close with the null pointer. Okay, this is address of this one. Okay, so remaining is empty as usual. Here one thing you have to observe, the memory is fixed 0 to 9 partitions we are dividing the memory. So based upon the input of the elements, it is placed the respective positions. Is there any restrictions to add the elements? No restrictions. How many elements if you want to enter in that location, it can connect it in the linked list form. So there is no overflowing concept. Only one drawback is, if you want to search fifth index, it can take time to locating the respective element in the list. It can take, searching time is high, inserting time also high, deleting time also high, time complexity is high, there is no collision. It is pure, it is resolving the collision. But the thing is, if the same position, suppose 20 elements you need to add, yes, you can easy to add, but it can take a time to take a position to add the element. If the insertion can take a more time, automatically searching is take a more time to search the respective element in the particular index point of view. So like that, if you not at all to restricting the extension of the list, that is ultimately time complexity is increased for insertion of the element, time complexity is increased to search the element, time complexity increased to delete the element. So these are the major problems in open hashing, that is a chaining process. Okay, this is a chaining. Why we call as a chaining or linked list means, from the index point we can extending in the form of linked list. Okay, so take some more key spaces. You can add number of elements in the memory. If it is same index 2 or more, you need to add, so then add at the end of the index position. Like that we can continue the list. How many number of elements we are going to add, that number of elements we can add through same index. Okay, so this is one method to resolve the collision. Even though it is resolve the collision, it can take high or more time complexity to insertion, searching and deletion of the particular element in the list. Okay, I hope you understood. Okay, so problem is time complexity is high, so take any other suitable solution without extension of the connections. Okay, so that's why it is called as the open hashing. Okay, memory is restricted, but other side we are extending the adding of the elements, that is the open hashing. Okay, closed hashing means we can do within the memory block only. Okay, next we will discuss about closed hashing.